So we've been looking at APIs. We're going to look at some more APIs, and we're going to be looking at the Randomuser. So once again, we import requests, and we import JSON, and then we make our get file, and we're going from Randomuser API, and we make that the variable R. We print R, and then we load the content here and print the result. And the only thing from the result we want to print later on is just the gender. So there we go. This is the header file up here. This is the part of the whole response. This is the results section. This is all the information that we were really interested in the Randomuser. And then, as you can see, from the result, we look at the results section, and then we use the first row of those results, and we look at the gender section, and all that pops out is female. If we look at 5A, we do the same thing, but notice the API call, we get one row of data. If we change that to a question mark and results equal to 5. If you are familiar with HTML, you can see we are adding variables that we are passing to the web browser, through the web browser to the other web server. So we are passing results equals 5, so there is a session variable that would occur on the web server that has called results that has a 5 on it. And so now we have 5 rows of data that come back from the API. And sure enough, there are the 5 rows. Again, we have the header, which is a response 20, and then we have the 5 results here. And we again are just printing from the row 1, row 2, row 3, row 4, and row 5, and printing out the values we got from gender. If we run it again, you can see we get a slightly different makeup of the people from our random fake users. How we're doing here is the exact same thing, but instead of just printing gender, we're going to print their from the name, their first, and then their gender. So we'll have the name and then the gender from the fake Randomuser site. Okay, so we again get 5. We get the first name. We do send the gender, but here we now take the data we got from the Randomuser file, take the first name out of that, and we now send that file to the Genderize. And you can see that we get we only did it for 1. We only did it for the first row here. And the Randomuser gender, it was female, and we asked Genderize based on the first name what the probability was, and we get a 100% probability that it would be a female, and it matches up. If we look at 5D, we're going to do the same thing, except we're going to look formatted a little bit different. We now are printing out the probability for their actual and their probability, and we go from there. You can see we have all the results that we wanted, not just the name. So we're pulling out all the rest of the stuff. This is what we are sending to Genderize to get those results. Look at 5E, we're going to do it twice now. We're going to do it for the first row, and we're going to do it for the second row, and we're going to check their gender, their actual fictitious gender, against what Genderize says. And so the first 2 is female and male, and again the probability is 99% that the first one is female and 99% that the second one is male. That's why we have the 0 and 1 here. If we look a little further, we can now do a for loop, so we can loop through all 5 of the values and check them against the Genderize website. So you can see we have an actual and expected. We didn't get anything back. Actual and expected, actual, expected, actual, expected. Here's one that is the actual and expected are different, and then we have 2 that were actual. and expected were the same. So you can see we're just pulling from the expected gender, which we were storing up here and here, and then the gender, it was actually, again, the fictitious gender from Randomuser. And finally, we can make it all pretty and put it into a pandas data frame, which is really where we want to get to. So we can go through and make that, and now we have a nice pandas data frame where we have their name, the real fictitious value, and then the expected value. This one is left justified, which is why it's right justified, which is weighted on the right rather than left justified. That's based on the language that's used there. This is really showing what the APIs can be used for. So not just getting random data. If we had real data, instead of using the random user data, if we had real user data and we wanted to be able to check it, we can then go to Genderize and check it and loop through and end up with a data frame of just the data that we want to work with. Same thing, but now we can ask how many names we want from the user. So we run this, we can say we want 7 names, and sure enough, it's going to come back. We get to 7 names. The response says 200, which means we had a good response from Randomuser. And then we do everything we did before, but the only thing we're going to print at the end is the data frame that has the real and expected there. And as it looks, we're all good. Now, what if we wanted to do some probability and add that as well? This is going to do what we just did, but allow us to repeat that. So we could do 2, and then it says, you want to try again? We do yes, and then we can do 3, and then we can say no, we're done. So we can do this many times. But what if we wanted to look at the difference between whether there was a difference between the probability and the year, the difference between the actual and the expected, and we'll do the same thing. We'll do it 4 times, and sure enough, we now have the differences where between the values, and in this case, they're all true. There's no differences. I don't know if we have any differences way on the right. Let's run this again, see if we get all left justified. We'll do 4 again. Yeah, now we get all left justified. And again, we have a difference column that now says they're all the same. And we'll do one last one. There we go. We'll do that again. We'll do no. And then we'll do the last one, which is how many names. We'll do 4 again. And this time we brought the probability in with us. So again, the differences, there are no differences there. Run it again, do another 4. And no differences, we'll run it again, do another 4. And we're not finding any differences. We saw the one difference, but so far we're not going to get any more differences. So again, we can build our data frame based on data that we're gathering from the APIs. And that's a common tactic when we're working with APIs. We're not just expanding, we're taking our data, we're expanding the information about that data by using the APIs. Again, we go to Randomuser, and now we take, again, we can have our response, which means it worked. We take our results. But now I want to show you how to access all this data in here that's so difficult to get to. So as you can see, we make title equal the results, the first row, the name section, and the title, and then we do the first and last name. So now we have these 3 variables that are available to us. So we can pull the individual data from this big mess. Now, this is even cooler. The Randomuser also has photos that are in response to they're not, again, it's all fictitious data. But the data then pops up here. Let me pull it onto this page, and that is the image that we've pulled from the Randomuser data set. So we've pulled the large picture, and we then have the URL for that, and then we're going to use the IO, and we're going to take the image and we're going to open it, and we're going to do an image show, which in this case is opening in a different window that I pulled into the video here. So we can do some really cool stuff with APIs, and I'll have another video up on that soon enough.